Okay, next we have to shorten this a little bit. It should be 35 millimeters, and it is now 42, so 7 millimeters to go. One of the things I must do, I'm gonna have to make some more tool holders for the quick change tool post. I'm gonna try this round insert tool. Should be pretty good for facing also. By the way, it's awesome to have the camera on a Mac base. Pretty good. Should be 38 now. Yes. So 3 millimeters. Should be 35. It's a little bit under, but that's well within tolerance. Okay, again tool change and reset. Okay, zeroing at the end. And the length will be 23 millimeters and the diameter is 63.3. So how much we have to take off? We have 5 millimeters, a little bit over 5 millimeters. Should be 2.5 millimeters to go. I think I should change my insert soon. Two and a half to go. That's 2. Okay, now let me turn the insert. Okay, so we should have half a millimeter to go. Okay, quite a difference. So actually I was wrong, of course it is still half a millimeter and not 40. I mean 60. It was supposed to be 60. So now we're still I took 30 off, so now it's still 30 to go. So now it should be 30. It's 32, 33. Close enough. And the final size will be 10 millimeters long and it's 59.6. $59.6. $61, $62. Now it's moving a little bit when I remove it. Okay, that's good. Now some chamfering. Let me change tools. Okay, again tool change for the boring bar. Okay, that's a virgin DCMT insert, as Keith Fenner might say. Zero the Z-axis first. And the X. One disadvantage about a lathe of this size is you have to take a light chip or hear that the tool is touching the surface of the piece. When you have a smaller and more sensitive lathe, you can just have the spindle stop and just crank the X-axis hand wheel until you feel that the tool is touching the piece. But on this lathe it's so heavy to turn that you cannot feel it until it's too late. So listening to the first squeaks or seeing the first chips fly is where I have to zero. So going for 60 millimeters deep and 45 millimeters in diameter. And the diameter now is, let's see, we are at 34.5, so it's over 10 millimeters to take off, and we need 60 millimeters of extension. Yes, I think it's just enough. So feed is 1600s per revolution. I think that's fine. And let's take chips of 3 millimeter, 1.5 per side. Maybe more, let's see how it goes. both the vacuum cleaner and the compressed air to clear chips. Sucking on one side and blowing on one side. So little over 4 millimeters to go. So let's take another 3. Still got some oil on the face. So another 3. Almost 1.5 millimeters. Let's take 1. Actually, let's do this in one pass because this is not a critical dimension. Okay, it's 93, it's close enough. So, now for the bearing races, and let's do some more setting. I guess I'm gonna show that to you since you liked the last one. Okay, let's repeat what we did last time. Here we have the bearing. Trying to get it out of the bag. Success. Let's see. It should be almost 50. Actually, I just had this mic inside and I was supposed to change the battery, but I forgot the whole thing and now I need it again. Let's see, it's a little bit over 50. Luckily this mic goes a little bit over 50 also. Just a tiny bit over. 50.29. Or 50.30, pretty much. Three thousandths of a millimeter is so little that it's difficult to comprehend how little it is. Let's go with 50.211. I mean 50.299. And now let me get the bore gauge. Okay, going for a tiny bit over 50. So this was a 40. So 45 and 50 is this one, and let's see if that's whoops. If the measuring range is enough. I think it is. Let's see. By the way, the indicator that's on the end of the bore gauge, it's a Soviet-made indicator, and it's a very high quality indicator. What's funny, I think what's funny about Soviet-made tools is they are almost always compatible with the European and the other standards, especially the European standards. As is, for example, the shank of the indicator. Okay, here we have it. Okay, very good. Now back to the lathe. Okay, so shooting for 50.3 millimeters. And now we are at 45. So 5 millimeters and a little bit over. Let me get my glasses. Okay, found the glasses. And let's zero again. Z and X. Okay, the depth will be 22.5. So we got 5 millimeters to take off, so let's do 2.5 in 2 passes, so 2.5 per pass. Seven and a half should be now. Yeah. So another 2.5, and then we should still have 30 to go. One disadvantage about bore gauges is that they require a lot of space in the Z-axis. There's quite a bit of springing going on. See if we can get a reading. It's about 35. About the same with the caliper. So let's do 25. In the last cuts. I think we're about 5 to go. 6 to go. Pretty close. And again shooting for 2 or 3 hundredths of press fit. That's very little to be taken off. It's a little bit warm also. But I think I'm gonna try to give a very fine finishing pass. There's some oil for you. Feeding out. My guess is we are right there. Let's hope so. Yes. It's 3 over. I mean under. I think I'm gonna give it a little bit of sanding because it's still a little bit warm and I think it will shrink another 100 and then it's a little bit too much. But first let's finish that. Finish what's left to do. So going for 8.5 millimeters and 43.15. I'm wondering if I should again set up the bore gauge. I think I should. Just a minute. So the very final thing to do is to make a housing for this seal. And let's see. .25 says the caliper. Let's see what a mic says. Okay, for measuring I'm gonna use this Chinese or Taiwanese made mic, which is pretty good. I have a set of Mitu Toyos, but they are inside the house in one of our living rooms now, so this is gonna work just fine. It's almost new. For just the sake of it, let's check the calibration. Let me get a rag. And my grandmother is supporting my metal working because she's supplying me with these very great rags. Clean all the faces. Let's see what kind of a reading we get. Maybe 1/4 over 0. So basically 0. Very good. And even if it was off, it doesn't matter in this case because it's a relative dimension. Just moving one dimension to another place. So it is 53 point. How come I'm getting a result like this? 53 and 15. and 17. So this ain't quite round, which is no surprise. Average is 53.16. So I guess I'll lock here. And actually, let's recheck with. So there's a difference of 1/10 of a millimeter in the readings of these two measuring devices, and that's very weird. I wonder how it's possible. But that's just the way it is. I'm gonna have to take a look at that, what might be the reason, but for now it doesn't matter. So the last dimension we were doing was 50 and a little bit over, so now we're doing 53 and a little bit over, so we're gonna use the little shim pieces, and right here we have a 3mm shim which we're gonna set in here, and we should be good. And for this size I don't have a digital mic. I have from 0 to 25 and 25 to 50 and then 70 to 100, but not 50 to 75. But I'm really surprised by the different readings of these two measuring devices. Both should be perfectly good, but they give such a different kind of readings. Really have to take a look at that. Okay, we're right there. So it's now 53.16. It's a nice new box. I've only used this for a few times. And actually I bought this new some years ago. I didn't have one, I needed one fast. So I just had to get one new. Okay, back to the lathe. Okay, here we are again. Let's check the length. Length is 8.5 millimeters. So we have 3 millimeters to take off. Right here I think the problem is with the mic. This is saying it's 400 under, which is pretty much exactly what we got with the digital mic and the bore gauge. So I'll have to take a look at that mic. Okay, 3 millimeters to go. Let's take 2.5. It's 18 under. So about 15 to go. So now we're 7 under. So can you see? So 5 to go. So now it should be 2 under, which would be perfect. Yes, we are. Actually, it's 3. Okay. A little chamfer, and then I'll recheck those both boards after the piece has cooled down completely, and it might require some sanding. Okay, but when I do this chamfer, let's do it. And when it's done, the lathe work on this part is completed. And next you're gonna see some milling of the hole patterns. Just a 45-degree chamfer. Just the full height.